Hello students, today we will learn about some easy technique to assign a reaction whether it will follow nucleophilic substitution or elimination pathway, and also how to assign the product of nucleophilic substitution and elimination reaction. So we will search for quick answers for such questions, and this will help the students who are going to appear for IIT JAM, NEET, GATE, CSI and NET, or the conventional BSc and MSc chemistry students as well. So before we start, we understand that there is obvious difference between substitution and elimination reactions. And the difference is that the substitution reactions replace one substituent with another, while the elimination reactions simply remove the substituent. Okay, so these are the basic differences between these two type of reaction pathways, and there are more specific differences, of course, that you will need to be familiar with later on. So with this I would like to start. So let's see. So we begin here with the question, is the nucleophile or base strong or not? Okay, so before moving into that one, I would like to say that a nucleophile is an electron-rich species that donates 2 electrons to carbon and forms a bond with it, whereas a base is also an electron-rich species, but it gives a pair of electrons to hydrogen atom instead of carbon. Okay, now of course a species can be of both a weak nucleophile and a strong base, so don't keep in your mind that a particular functional group or a molecule can only be a nucleophile or base. It can be of both. Okay, so first we will look for whether the nucleophile or base is strong or not. So this can have two answers, right? So if yes, the nucleophile or the base is strong, then definitely the reaction is going to follow the bimolecular pathway. That means the substrate and the nucleophile or base will appear in the rate determining step of the reaction. Okay, so it can be either of SN2 or E2. Okay, so depending on the reaction conditions, we will see that. The other way, if the nucleophile and base is not strong, so in that case we have to screen for the nature of the substrate. We have to look for that. Okay, I will come into that part later on. So first move on to the bimolecular reaction. So then again we look for the nucleophile or base, but this time we will be looking for whether the nucleophile or base is bulky or not. Okay, now this can have two answers, of course. First, if yes, the nucleophile and base is bulky, so that means the nucleophile was strong and also the nucleophile is bulky, then definitely the reaction is going to be in a E2 pathway. That is, a bimolecular elimination reaction will proceed and we will get E2 product. If not, that means the nucleophile or base is not bulky, so then again we have to go for looking the nature of the substrate. If the substrate is methyl or 1-degree alkyl halide, so in that case the product or the reaction pathway predominantly be the SN2, that is nucleophilic substitution bimolecular pathway. Okay, and if the substrate is 3-degree alkyl halide, it will again follow the pathway of E2 elimination reaction, and if the alkyl halide is of 2-degree in nature, so it can have it can be of SN2 or E2, either pathway. Okay, so now we see the other way, where the nucleophile or base given is not a strong one. Okay, so in that case we have to look for the nature of the substrate, and if the substrate is of 3-degree, 2-degree or highly stable 1-degree alkyl halide, in that case it will follow the unimolecular reaction pathway. That means only the concentration of substrate will appear in the rate determining step of the reaction. There will be no role of nucleophile or base in the rate determining step of the reaction. So in that case if the nucleophile or base is bulky or not, we need to learn that. Okay, so in that case, if the, there is again two option of the nucleophile, whether it will be bulky or the base be bulky or not. So if this is bulky, the nucleophile or base is bulky, it mostly follows the E1 star pathway. Okay, the E1 pathway. And if it is not bulky or the base is not bulky, so that means it will mostly follow the SN1 star pathway or SN1 pathway. Now by the star, what it means that under certain circumstances or certain reaction conditions that favor a unimolecular reaction which involves the weak nucleophile or base, or in terms of solvent it can be in presence of polar protic solvent, then we will get the mixture of SN1 and U1 as usually obtained. Okay, now we know that SN1 and U1 are grouped together because they always occur together. If the leaving group dissociates first, there is an equally likely chance of the nucleophile attacking, so it will follow the SN1 route, as there is the base pulling off the beta hydrogen that can lead to the E1 pathway. Okay, so in that case, mostly the E1 and SN1 in terms of the nucleophile and base bulkiness. Okay, so here one thing need to be mentioned, that in the beginning when we talk about the nature of the substrate, when the nucleophile or base is not strong, then if the substrate is of 1 degree alkyl halide and not there are not substituents that are going to make that more stable uh, or favorable for the reaction, so the reaction will be unfavorable for either E1 or SN1, so the reaction will not proceed further in that case. I hope with this you can easily distinguish from the reaction given and the reagents, that means the nucleophile and base given, whether the reaction should proceed in the nucleophilic pathway, nucleophilic substitution pathway or elimination pathway, and more specifically into the subcategories of individual type of reactions. Okay, so thank you for watching TG Chemistry, and do subscribe my channel if you like the video, and press the bell icon to get notification further to get more videos if I upload. Thank you.